In these series of lectures, I'm going to talk about a concept called GameFi. GameFi is basically a Web3 integrated experience inside of our traditional games that we know and love, using decentralized compute networks like Ethereum, Algorand, Solana. This course will really just talk about Ethereum and its use case, and I hope you enjoy it. So the first lecture is going to really be about the ERC20 token. Now, when we think about an ERC20 token, we have a smart contract that has the logic and then the asset, which is a fungible asset. Now, you may be asking yourself, what is a fungible asset? And when we think of fungibility, let's take a dollar bill. I can exchange that dollar bill for any other dollar bill of the same denomination. So in these slides here, we have a $5 Canadian dollar bill, and I can exchange that with someone else that has the same denomination. So there's fungibility. They might have unit notes that are different. The actual number of the printed version of it is different, but they're fungible. They can be interchanged with each other. Another concept of this is the MicroStrategy stock. If I buy a MicroStrategy stock, I can exchange that for another MicroStrategy stock. They're fungible. Now, when we think of ERC20 tokens, how are these used in the blockchain game development framework? Typically, they can be used as protocol ownership, owning a piece of the protocol, staking it and getting rewards. It also can be used for governance, voting on specific updates to the platform. In a game development of sense, we can look at this as voting for maybe new games to come onto the protocol, some grants that might be given out. You can kind of use your imagination on how that would be orchestrated on the network or chain. The IOU doesn't really have a particular mechanism as you would know in traditional finance. But if we look at it in a game sense, an IOU could be like where we onboard a user with fiat currency, and they get game tokens and get game tokens sent back, and we use those game tokens to purchase in-game items or something like that. Now, the ERC20 standard, developed by Fabian Vogelsteller and Vitalik Buterin, is the standard that we use to create our in-game tokens. There's a set of interfaces or functions that we need to integrate into our smart contracts that give us this functionality and fungibility, and also with working with our wallets so that when we create these tokens, that wallet developers can understand what our ERC20 or what our in-game token is. So it's very important that we use these standards in order to create our in-game tokens. Now, let us look through some of the components that make up an ERC20. So we have a name. You'll see here that it's actually optional. And the name will just be the name that we have designed for our token. You'll also see here that we have a function signature and a function implementation. So the ERC20 standard has these default functions and they have a default implementation. Now, we can override this as long as the function signature is the same, and we could add in some additional functionality. But just take into account that when you're creating an ERC20 token, that there are certain functions that we need to have in our smart contracts, but if we wanted to add additional functionality, we can override these functions and embed that into it. You'll also see here that we have a symbol. Now this is also known as the ticker. And when you are, say, on CoinMarketCap and you see these, the actual token that you may want to invest in or get some more information on, it's not the full name of the token. It's a, usually 3 to 4 letter abbreviation of the token itself. We also have the decimals. This is kind of like the granularity of the token. The base granularity of ETH is 18 decimals, but there are some other contracts like USDC, which is 6, and some other ones that have different granularity. When you're starting off with creating an ERC20 token, you'd want to stick with the standard, and that makes it easier for when you are dealing with the fungibility of not only your own ERC20 token, but other ERC20 tokens as well. Something to keep in mind. Here we also have the decimals. We have the total supply, the balance of, which gives you the balance of the amount of tokens that a user has at a specific address. And we'll see a lot more of this as we continue to work with it. Some of the other bigger ones here are the transfer, which has been updated in more recent versions of the Solidity programming language, better ways and more ways that we can do this that are safer. Then we have the transfer from, where we have the address from the address of where we're going to send this token to, and the value. Now we have a delegated transfer, which has an owner, a spender, and the ERC20 token that we want to work with. And in order to do this, we also work with things like the approve function, where we approve a certain amount of tokens to be spent on a particular user's account. And you can see this in this slide here, where we have this approval function, where we have the address of the spender, we have the value or the amount that they are approving to spend, and we also have things like allowance, where we can have the address of the owner and have an allowance of a certain amount of tokens which they can spend. And also these will emit an event on chain, and we can, in our games, read these certain, events that are being triggered through the actual smart contract. Okay. Now let's kind of take a look through a higher level understanding of this. So say that we have an investor or a game developer, right? The first thing they're going to need to do is they're going to need to integrate, or they're going to need to interact with the DeFi or GameFi protocol and approve a certain amount of ERC20 tokens. Once this has been completed, now the investor or game player can call the deposit function to the DeFi or GameFi protocol, which is the spender, and then they can transfer from the investor or game player to the DeFi or GameFi protocol a specific amount of tokens, and this would be done with an ERC20 token. Okay, so now let's go and create a few simple contracts. Just going to move this over, and we will create a new token. I'm just going to call this token and open Zeppelin. .sol. Now we're going to make our lives easier here, and I'm going to just add in our license information and the Solidity version. Actually, I'm going to make this 2.6. Can I get this out of the way? I'll just click Grammarly. Get Grammarly out of there. Okay, so the one thing that we should be doing when we're creating our ERC20 contracts is utilizing the Open Zeppelin's contracts. They're audited already and have the base functionality, and we don't have to basically do all this from scratch. So I'm going to say import ERC20, and this is going to be from at Open Zeppelin contracts token, and then we have our ERC20. I'll just close this up here. Now we will create our smart contract. I'm just going to say token Open Zeppelin 1 is an ERC20 smart contract. Now, this basically allows us to inherit the properties of the ERC20 contract that Open Zeppelin has defined for us. So now we will need to create our constructor and our ERC20 token. And now we'll have our token name as we described or saw in the slides, and then the token and ticker, which will be how people will see our token. Now, that being said, this is a fully functioning smart contract that inherits from the ERC20 standard. So if we go and compile this and deploy this contract, you'll see here that a lot of the functions that we were talking about inside the standard are already here for us. So if we click on name, we got our token name, our symbol as our token symbol here. But this is a very useless token because we don't actually have any tokens to use. So let's go here and we'll copy this contract. We'll paste it here. We will update the name of this contract. And the only thing that we're going to do differently here is that inside of the constructor, we're going to call the mint function. Now we're using the underscore mint because we're using the implementation that is found inside of the inherited ERC20 Solidity file. So we'll have the underscore mint, and it will say the message.sender, and we will just say 100,000 tokens. Okay. And that being said, this also is a fully designed contract. What we'll do here is that we will, oops, got to recompile it. Let's recompile this contract here. Okay. And then we want to deploy the version 2. So I'm just going to delete this here, and we will deploy. Now, we're going to see the same things. The decimals is standard. We didn't overwrite that. But when we get to our total supply, we'll see that we have these 100,000 tokens. Okay, so let's do a little bit more, make our token a little bit more advanced. So let's copy this again, and we're going to paste it. I'm going to name this number 3. And the one thing that we're going to do here is that we don't want to basically mint this in our constructor. What we want to do is create a type for our address. This is going to be public, and this is the admin. Now, what we want to do inside of our constructor is we want to say the admin is equal to the message sender. So this is just referring to the deployer of the smart contract. Now, we are going to, instead of using the mint function from the ERC20, we're going to basically create our own mint function. So we can just say function mint, and usually when you're overriding, you will just name the function what the name of the function that we're overriding, but minus the underscore. So we're going to have the address of 2. We're going to have an unsigned integer for the amount. And this will be external. And we want to require that the message.sender is the same as the admin. And if it's not, we want to basically say that only the owner can basically call this. All right. Now we can call our mint function, and then we'll pass in the 2 and the amount. Okay, and again, so we're seeing here that we're just allowing the mint to be called from outside. So let's go back here. We will compile our contract. I'm just going to remove these. I'm going to look at the number 3 here. We will deploy this. And then you can see here that we have the ability to mint this to another address. So I'm going to copy this address here, but I need to go back to the deployer. Well, actually, you know what? Let's, I'm going to go here, and then in the mint, just to prove a point, and let's just say 10 tokens, and we're going to transact. And you can see here that we get this error because only the owner has the ability to mint, and that's exactly what we expected. So let's go back here. We'll go to our deployer, and we'll do the same thing. And you can see here that we are able to mint. Now, when we're creating our games, something that's really important for us to do is to have some, test tokens, right? So let's do basically the same thing with our third smart contract, but allow it to be used as a faucet. So I'm going to just copy and paste this because the functionality is retrospectively the same. I'm going to update this contract to be named faucet. Now I'm going to remove the admin here because we don't need that. I'm also going to remove this admin inside of our constructor because we don't need that as well. And we also don't need this require. Okay, we just want the ability to mint. So let's close that. Now I'm going to go to our Solidity compiler here. I'm going to recompile this. And then I'm going to deploy the faucet. Okay. And now to test this, let's do the exact same thing that we did before. I'm going to choose another one. I'm going to copy this address. Oops, wrong one. I want to copy the account. And now we can go to the mint. And I'm going to say 2. And I'll just say 100. And then transact. You can see here that that was successful. And if I take that account that just minted it, and I want to see the balance of, I can paste that in and call the balance of, and you can see 100. So that is the first video on our GameFi using ERC20 tokens. We've created some very basic, simple tokens, but it also shows you some of the constructs and things we need to think about when we are designing ERC20 tokens in our games. See you guys in the next video.